So hi, my name is Ken Miller, and I am the founder of a company called Brew Robotics, and this is a Zazbot. It's a three-wheeled Omnibot. It has basically 3 DC motors in it, and there's really no sensors on it at all right now. There's no encoders on the wheels. We're driving with a smartphone, so it can go instantaneously in any direction. I'm sorry about that. And I'm going to do a more formal presentation in a couple of months because we still have some issues with the software. Because there's no servos and it can spin, when we drive it, it starts to drift. So we have an IMU in here that has accelerometers, a magnetometer, and gyros. And we're working on a program to take those into account so that we can maintain our course. So that's really the last hurdle we have on this project. And it's essentially it's meant to play games. So the games are primarily pushing balls around. So the first game is to play on a pool table. And it's meant to be a competition game. So you have put the balls in the middle of the table, and you can play a game of stripes and solids with 2 robots and two controllers. And you play a game of who can push the balls off the table first. And then we start to expand that into a stadium that we build ourselves. That's going to have gates around an enclosed area. And those gates will be incorporate some features from miniature golf. They might have gates that open and close. We'll have sensors that sense when the balls go through and what balls go through, so you can play scoring games. And we just keep adding functionality. This is it's really a technology platform. So let me just show you here. Hang on. So these modules, they all come off, and there's we pass through a set of pogo pins, power and signal up the stack. So there's really unlimited technology that we can add to this. We can add any sensors, we can add cameras, we can add projectile launchers, just about any sort of technologies. You know, smoke detectors, microphones, speakers, just about anything you can think of. So I think that's really all I want to get into today. Just did a quick intro. I can drive around a little bit. If you're interested to see it. So right now we have LEDs in the dome. There's 12 LEDs in there, and we have 6 LEDs on the bottom. And let me turn on the phone here. So we have a little app, and we use the accelerometers in the phone to drive it. So it's a little, and we can spin. That's probably the best thing to show. But basically, as you just tilt the phone, and it goes in the direction you tilt it. But as I said, as you because of the problem with drifting, it doesn't maintain its course. So that's what we're working on. So if anybody here thinks they can help us with that problem, please see me sometime after the meeting. Thank you.
All right, this is Locomo, Smart Table, Locomo, the Smart Table. It's a table that can get from one place to another and back again in an unstructured environment. So this is the BotVac package with raw serial, the ultrasonics. The BotVac package allows you to map and navigate, but if you want to extend it to additional height, so here's my map. Okay, such that it is. I've driven around and created this map. And so now, without any further ado, here you can see the robot. This is all 3-dimensional. See? Actually, move it around. Move it around. It's a big, wide open room, so it's really a tough to map. Regardless, the concept here is that I need to go up. I can't see it. And left is right and right is left.
That's a map from something called RViz that has shown.
Yes, this is raw fish. Oh, look, it's flipped upside down.
Yeah.
Isn't that?
No, it's reversed left to right.
It's left to right.
Right.
All right, now how much would you pay? What's going on now? Bear with me, sorry. Who's driving this thing? Yeah, it's funny, huh? Okay, so look, here's what we're going to do. Okay, bear with me.
It's fine.
Yeah, it's all good, right?
He's in the underneath.
Okay, here's the deal. Here's the, what's under here? No, I can't curse here. So,
You can.
okay, so there's something. Okay, so let's come up. And I'm trying to get what is backwards.
You know, Cap, why don't you just send it someplace and see where it goes?
Well, here's my pose. Exactly, that's what I'm going to do. But I have to find see, is that must be the location. We're going to do that.
So that actually looks right.
Yeah.
So that's the, okay, so I'm going to come down here, and the robot now shall navigate, let's see here, coming down, over here. Yeah, this is the each person challenged. Okay, clicking here, okay, so I'm going to have the robot navigate here, left is right, right's left, up's down, down's up. And I mouse up. We should see some path planning lines. Now I'm going to, let's see. Oh yeah. Wait, there's more. Is the robot moving?
Zipper.
Move a little.
Well, I'm gonna move him in a second. I'm trying to get my DOS. There it comes. Okay. Here comes the DOS. Did I say DOS? That's funny. Well, now I've got teleop. We'll be driving around. I think I can do that.
Okay.
So you actually see him moving on the map. Never mind the man behind the curtain. And there, where's Mark? Mark?
Which one? Yeah.
Johnson?
Yes.
Some teleoperation, some teleop going on there. Richard, I see you. Can you see me?
Hello.
I turn on the microphone, but there'd be all kinds of feedback, and with as much fun as we're having here so far. So I'm just going to actually check this out. I am actually navigating using the. I'm navigating using the
Can you slide your screen over a little bit because it's being covered by the conference stuff and people can't see the
Yeah.
Yeah, now I'm out of control, see, because my screen's on the other side.
Slide arm is.
Yeah, but this is
Slide arm is to the right.
there it goes. Is it that way?
His left.
There it goes.
He's still trying to go backwards.
I know because I can't. Oh, you know what? Thank you, Richard. Richard's a wise guy here. He actually picks up the robot so that it doesn't do it. Big hand for Richard, folks. Bear with me. There we go. Stop. Anyway, presentation difficulties notwithstanding, with Ross. Now I'm going to curse.
Are you telling it where to go, or is it telling you
No,
where to go?
I'm out of control again. Bear with me.
Okay. Tell me when. It came to me. There you go.
David, Wyland, so nice to see you. All right. Again, what we're doing here is driving this vacuum cleaner around and creating a map with Ross. You're saving that map that you can navigate within that map. I've extended it with ultrasonics. This is used for navigating so it doesn't go under tables and under couches. The problem with it is it's still noisy. It's got like artifacts all over. I'm having to clean it up with the clear cost maps and stuff. But you know, three things for me is delivery, telepresence, and AI. Okay, Google, where's the Homebrew Robotics Club?
Sorry, I don't know how to help with that.
Okay, Google. What about donkey car?
Sorry, I don't know how to help with that.
Okay, Google, what time is it?
7:39.
Yay. So, I'm not above Velcroing a Google Mini to my robot. AI done. Google.
You did have a
Big
race
round
off
of
between
applause for
Google
Google
and-
here, huh? All right. Questions, comments? I'm done.
For those who are new, actually Camp has done this demo several times successfully.
That wasn't successful?
It's really neat.
Come on, it's comedy, buddy. It's comedy. It's probably successful.
Yeah, so I think, I don't know if you defined it, but ROS, Robot Operating System, is open source software that a lot of people use to do autonomous navigation. And there's actually a meetup for ROS. Do you want to mention your meetup?
Yeah, we meet on Rains Gloria, Felix, and one of the co-organizers of S3 Ross. And Alan is in the room. Alan, can you raise your hand? He leads a monthly meetup at the Hacker Dojo, third Wednesday of the month. And then I do a spin-off at the Palo Alto Library for ROS tutorials.
Great, thanks. Yeah, so ROS is used a lot in projects, both hobby as well as commercial. Would you like to go next?
Yeah, I'm all ready. So, hello everybody. We build this guy here. It's called Magni. It's a robot that can carry a payload of about 100 kilos. I'm actually 121.
Wow.
So, of course, it can drive around in that. Plus, we've imbued it with all kinds of capabilities. I mean, in the past, I've shown our navigation demo. Can I plug in?
Yeah.
Sure. This, I can do either. So, you know, in the past we've done navigation demos, and we could show that today. But today, what I want to really talk about is we've imbued the robot with deep neural net image recognition capabilities. If we can bring it up, right? And you know, we want to start to try to explore some of the behaviors that we can do with that capability. And thanks for that. So, let's see if I can just move this guy over. All right. So this is an image that I captured earlier, actually while just setting up the demo. And what happens is that the robot can look around the room and it can find objects. So in this case, it's found a person, and that's the confidence with which it's found a person. Sorry, it's all mirrored on this display for some reason. I don't know why. It looks great on my screen.
That's the same problem I had.
But it can look around and it can find about 20 objects. It can find about 20 objects, and we're starting to try to create methods or that we can use to interact with those objects. So, for example, you know, let's say you wanted, obviously, the robot to bring you a non-alcoholic beverage. You might want to teach it how to do that. And so, for example, I'm just going to initiate a program that's going to look around the room and try to find a person. And when it finds the person, if it finds the person, it's going to sort of line up on that person, and it's going to try to drive towards them. So let's see if the robot, I should try to hide because otherwise it might find me. Right? Let's see if the robot is going to do this. Oh, it's already found someone. It's already found me, I'm afraid. So let's try to do that in a bit more of an exciting way. See, it found me even though I was scooching behind the podium. So I'm going to try to hide even more. Maybe we turn it like this direction. Don't be any people. And see if it can find someone. So there you go. It's not finding anything there. That's just something we have to clean up. And it's going to turn again. There you go. It's turning.
It's gotta find you.
Find you.
Gotta find
It's
you.
gonna find me. Hi.
Okay, I don't think it's been found. Did you?
There you go. She's found
Bill.
Bill.
found Bill,
Bill.
and then it drove towards him with the beer. So,
Oh, nice.
and you know, this is a capability. We can get it to find other things as well. So, for example, one thing object that's commonly here is a chair. So I'm just typing in the same command line option, and instead I'm putting in chair. So it's going to look around and find the first chair that it can see, and it's going to try to drive up to it. So you can see that this has got people on it. It's finding people. It's finding people. It's not finding anything, of course, at all there. And if we can get a clear view of a chair, it may try to drive
In a
towards it.
target-rich environment.
Yeah. Yep, it's found a chair and it's driving towards the chair. And so we think that this kind of thing will help all of us build lots of other cool robots. All right.
Bring me up here.
Yeah, there you go. Bring me a beer is coming. Combining that with the voice recognition that we've shown in the past. So, all right, thanks very much, guys.